Hello, I will talk about special relativity and the twin paradox. Special relativity is an explanation of how speed affects mass, time, and space. As an object approaches the speed of light, the mass of the object becomes infinite, and so does the energy required to move it. This means that it is impossible for any matter to go faster the speed of light or even reach the speed of light. Now I will talk about the twin paradox. The first twin flies into space at a very high speed, for example 240,000 kilometers per second, and returns to Earth while the second remains on Earth. According to the theory of special relativity, movement at high speed slows down the flow of time. So the brother who went on a journey in space will return to Earth 10 years younger than his brother who stayed on Earth. Now I will describe the paradox in detail. One twin remains on Earth while his brother moves away in a spaceship at a very high speed, close to the speed of light. At some point, the brother turns around and returns to Earth. According to the theory of relativity, the journey in the spaceship will take less time than on Earth, which will lead to the brother in the spaceship returning younger than the brother left on Earth. For example, suppose the journey is to the star Epsilon in Eridanus, which is about 10 light years away from the solar system. And the speed of the spacecraft is 80% of the speed of light, that is to say 240,000 kilometers per second. According to the twin left on Earth, the round trip time as measured on Earth is T naught equals to 2 times M naught divided by V. So it is the total distance back and forth. That is the reason that we are multiplying by 2 the distance from Earth to the star Epsilon, and then we divide it by the speed of the spacecraft, that is 240,000 kilometers per second, that is 80% of the speed of light. So the total way back and forth divided by speed will give us the total time that it will take to do all the journey. That is 2 times 10 divided by 0.8, and the final result is 25 years. So according to the brother that stays on Earth, the total time that passed while his brother was doing his journey is 25 years. And according to Lorentz transformation, the time measured by the twin in the spacecraft is T spacecraft equals to T naught T naught is the total time that his twin brother measured on Earth, that is 25 years, multiplied by root of 1 minus v squared divided by c squared equals to 25 years that brother that is on Earth measured, times root of 1 minus 0.8, that is v divided by c, and the final result is 15 years. So because of the fact that the twin brother that is in the spaceship travels at very high speed, then the rate of time flow in the spaceship will be slower than the time flow on Earth. This phenomenon is called time dilation or time lengthening. His journey will be 10 years less than the time that is passed on Earth. According to the twin in the spacecraft, he is at rest, while the Earth on which his twin brother is and the star Epsilon in Eridanus are moving across it at a speed of 80% of the speed of light, that is 240,000 kilometers per second. As a result, the distance between them shrinks according to the Lorentz transformation. So the distance it must travel is L spacecraft equals to L naught. L naught is 10 light years, is the distance between the Earth and the star Epsilon, according to the measurement from Earth, times root of 1 minus v squared divided by c squared equals to 10 light years is the measure of the distance between Earth to the star Epsilon when we measure it from Earth, times root of 1 minus 0.8 is the v divided by c, is the division v by c squared, equals to 6 light years. So we can see that the distance from Earth to the star Epsilon shrink to 6 light years, from 10 light years to 6 light years. So it shrinks in 40%. And when someone or something travels at very high speed towards you, there will be a contraction of distance between you and the object that travels at very high speed, according to special relativity. So there is a contraction of distance, because of the fact that from the point of view of the twin brother that is on the spaceship, he is at rest, and the star epsilon moves towards him in a very high speed that is 80% of the speed of light, and that is the reason that there is a contraction of distance according to special relativity. So the distance from Earth to the star epsilon contracted from 8 light years to only 6 light years. So the total time that it will take to the brother in the spacecraft to travel back and forth from the Earth to the stars, epsilon, and back to Earth will be T spacecraft equals to 2 times L spacecraft divided by V. So the total distance that the twin brother travels is the distance between Earth and the star epsilon as he measured it when he is traveling in very high speed, that is 6 light years. And actually, because of the fact that he travels back and forth, the total distance will be 6 light years times 2. So the total distance that he travels is 12 light years. So the way is 12 light years, and the speed is 20% of the speed of light. That is 240,000 kilometers per second. So the way divided by speed is, of course, the time. And the total time is 15 years. So it is 10 years less than the time that is measured on Earth by the other twin. So there is, therefore, the two twins effectively agree that the twin in the spaceship will be younger when they meet again, in terms of the twin that remains on Earth due to the effect of time lengthening or time dilation, and in terms of is the traveling twin due to the contraction of distance. Okay, thank you very much.